Hi, welcome to my channel and another experiment with the Arduino Uno. In this experiment we're going to produce some musical notes with the Arduino, and each one of those notes will be played as we press one of these switches. I like how this starter kit, the book introduces some concepts on the hardware and software side, sort of incrementally as you progress through these chapters or experiments. In this one we're being introduced to the concept of an array. So we have 4 notes, and the frequencies associated with those notes will be stored in an array. And as we press one of these switches, a resistor or resistive ladder will vary a voltage on A0 that will be associated with each one of those frequencies. If the voltage falls within a certain range, a particular note will be played on the piezo. So let's take a look at the circuit and then run through the program real quick. So here's an example of a resistor ladder, and as you press any one of these switches, a proportion of the total 5 volts will appear here, and that's where we'll hook up to A0 on the Arduino. Here's a different orientation of the resistors and the switches, and we're only using 4, but you can see here V in will be applied here at A0 on the Arduino, and we have a 1 megohm resistor, a 10K, a 220 ohm resistor, and then a 10K to ground here, and then here's the piezo connected to pin 8. So let's take a look at the program. So again, these experiments and programs are in the Arduino project book that you get with their starter kit. So we can see here this is an integer variable of array type. And it's similar to a regular variable, except it's followed by these square brackets. And then these are the elements that are going to be in that array. And in this particular array we have 4 elements. And these numbers associated with these notes. These are, I don't think they're specifically frequencies, it's just that these are representative of these particular notes here. C, D, E, and F. Within the Arduino itself. And it's mentioned in the book that this variable, this array, is being declared outside of the void setup. So this is a global type array. It's not hidden within another loop or function inside the program. It's outside. Next we're going to initiate the serial port communication so we can look at data in the serial monitor. So we have void setup, serial.begin 9600 baud. Next we will set up a loop here that will do an analog read of the voltage at A0 and return a digital value and store that in the variable keyval. So here we'll print on a new line the value in keyval, and here we are going to look at that value, and depending on what range it falls within, play one of these 4 notes, C, D, E, and F, and we'll do that with a series of if and if-else statements. Here the maximum, of course, out of the onboard analog to digital converter is 1023. So if keyval is equal to 1023, we're going to call the tone function, and on pin 8 we will play the note that's located here. It says 0. So one thing I need to mention here is that with an array, this is indexed. So these elements aren't referenced directly, they're referenced by position. So this is the 0 position, So this is element 0, element 1, element 2, and element 3. So here we want to play the note that's in element 0. So it'll place the note C. Else, so if it isn't equal to this, else if key val is in a range here that's greater than 990 and key val is less than or equal to 1010 coming out of the onboard analog to digital converter, it's the digital value, we want to play the note that's at position 1, which will be D. And so there's another tone function being called. And we do the same thing here for the next range of values. We're calling at pin, so that's E. We're calling to play E if it falls within this range, greater than or equal to 505 and less than or equal to 515. And then last, we have F. So if key val falls within this range, greater than or equal to 5 and less than or equal to 10, we're going to play F on pin 8. Now the last thing we have to do though is if no switches are pressed, there's a function, a no tone function, so there'll be nothing produced on pin 8. And that's the program. So again, it's interesting how we slowly are introduced to these concepts here. So this is a really valuable function or a concept in programming, is the use of an array. Gives you a lot of flexibility in manipulating data and storing data. So let's hook up the circuit and see it at work. So let's upload the sketch. There's the receive and transmit LEDs flashing. Let's see what happens here. So here I believe we have middle C, D, E, and F. Now can you hear how E and F sort of sound like they're fluttering? They don't sound as clean as C and D. And that's because of the voltages, they're sort of unstable, and you have to play, I guess, with the tolerances on these resistors. I've tried some different values that I've had on hand and was able to improve it slightly, but so what the problem is here on, say, F, the range of value here is between 5 and 10. And I've lowered this value, 5, but then you start, it starts to pick up noise. So even sort of like putting my hand near it will get that voltage jumping on A0, so it starts to register a note. And like I said, you can also try to adjust the resistors. But I only have some standard values and wasn't able to really improve that too much. So you can see here, even if I try to measure the voltage at A0 without any buttons pressed, it fluctuates the voltage at A0 enough that I end up with some static coming out of the piezo here. I was wondering if putting a capacitor to ground on that pin would help. Now let's look at the digital output from the analog to digital converter using the serial monitor program. So we'll press C and we'll see the output from the analog to digital converter. See that it's 1023. That's a nice clean note. D, 1002. Again, a nice clean note. E, it's some fluctuation there, 510, 511, 15. So it's jumping around a little bit. So if we would have changed the range on the values there for playing E, we might be able to clean that up a little bit. And this is just really iffy here. We have it jumping anywhere from 0 to, looks like 11, 13. That's why it sounds like that. If you look in the program here, I just adjusted these values. I lowered this down to 500 and here increased it to 520 from 515, and when I press E now, it's a nice clean note. You don't have that fluttering or stuttering going on anymore, or static. So C, D, E, and F, still a problem though. The problem with F is if I lower this, you know, even close to 0, it just picks up, it becomes sensitive to just touch. You put your hand near it. We'll try that. So we can adjust this, I don't know, 2, and then maybe this to 15. Oop. So we'll upload that. Try it out. I'm just touching the button. It is cleaner. It's cleaner as long as the button's pressed. So you can see here, even if I get close to, I just put my finger on it. It's like a Geiger counter. But if I press it, it's a nice clean F note. So that's the keyboard experiment with the Arduino Uno. And we built a resistor ladder with some switches that we used to vary the voltage on A0. And depending on what voltage was applied, would play a musical note, C, D, E, or F, that we stored in an array. And we used the tone function to play a note on pin 8 on the Arduino. So, thanks for watching. Please subscribe and or comment, and see you next experiment.